Hi guys. So in this lesson, lesson 3, you're going to start looking a little bit more at those irrational numbers. So we're going to be focusing over on this side where pi is and where the square root of 2, square root of 6, square root of negative 17, all of those are. Okay, so those are our wacky numbers that go on and on and on with no pattern. Okay, when they're converted to decimals. So an irrational number up in our keywords, it cannot be obtained by the division of two integers. Okay, so like anything that could be written as a fraction, that's not an irrational number, okay? They're giving us this definition that if it's irrational, we can't do that. We can't write it as a fraction, okay? And a rational number, in a rational number, we can write it as the quotient of an integer divided by another integer, okay? Quotient meaning division, and division meaning that fraction bar, okay? Remember that 3 over 5 means 3 divided by 5. Okay, so if we look at those together, if we can write it as a fraction, it's rational. If we can't write it as a fraction, it's irrational. Okay, this is another way, this is a shortcut. Okay, if it's a repeating decimal, okay, that's rational. There is a way to take a repeating decimal and rewrite it as a fraction. If it's a terminating decimal, that's rational. Okay, that means it ends. And if it ends, we can use place value to create the denominator of the fraction. So look at this problem from your quick check. This is yours. This is free math. So it says, identify which condition is necessary for a number to be rational. Okay, this is some pretty fancy wording here that they have. So I'm just gonna I'm gonna break this down a little bit. Okay, let's say it a little clearer. So what they're saying here, what condition is necessary for a number to be rational? What they mean is which of these choices must be true. Okay, that's all they're saying here. So number 1, it must be able to be expressed as an integer divided by a non-zero integer. That sounds a little familiar. It must not be an endless decimal. I thought those endless decimals meant they were rational. This sounds like the opposite of what I want. It must be written as a fraction. Well, not necessarily, because if we had 0.3 repeating, we would still say it's rational. Okay? I don't think it has to be written as a fraction. It must not be negative. So look at our chart. Remember that the rational numbers have the negatives in them. Okay? Look, here's one right here in the examples, negative 3.56. So I don't think that's true, that it must not be negative. Let's cross that one out. And then let's look again at this first choice, which sounds pretty good. First choice says it must be able to be expressed as an integer divided by a non-zero integer. Key words, look at this. Integer divided by a non-zero integer. And rational, a number that can be expressed as the quotient of an integer divided by another integer. Okay, so necessary for the number to be rational. Here's the definition of rational. So I think we're good to go with this first choice. This is correct. Okay, we must be able to express it as one number over another number, a fraction, numerator over denominator. All right, let's look at another one. Oh, okay. Which of the following is an irrational number? Okay. So remember, rational, it can be a fraction, but it has to be integer over integer. Okay. Look at the first one, 1 and 5 over 29. Okay, if I wanted to, I could rewrite this as an improper fraction. You learned to do this in 6th grade, maybe 5th. This would be 29 plus 5, 34 over 29. This is rational. Okay, look at the next one. This one is 0.34 repeating. Repeating decimals are rational. This repeats. Okay, look at the third one. Okay, this one's the irrational one. And I'll show you why. Square root of 2 over 3. So you guys, the square root of 2 looks like this. Oof, look at that. Okay, 1.414213, blah, blah, blah. 1.4142, and then it keeps going over 3. Okay? Remember, rational has to be integer over integer. Okay? Square root of 2 is not an integer. Okay? Square root of 2 is not an integer. So, this one is irrational. Because the numerator is not an integer. You guys, you're home and there's no other students around. Say that word, integer. Say it out loud, integer. The last one, 87.9821. This one ends. It terminates. Okay, so this is rational. Okay, so this guy here is the irrational number. That's the answer for your practice number 2. And the reason is the first choice can be written as a fraction. The second choice is a repeating decimal. That's rational. And the last choice is a terminating decimal. It ends. It terminates at the end there. Okay? The one with the square root of 2, numerator is not an integer, so it is irrational. Let me see what else is on here. Oops. I don't want to take too long, but there were some hard problems in here. Okay, so I wanted to show you how to estimate. Okay, so this one, 9/4 is close to the square root of what integer? Okay, so when they say close, that's when we're talking about estimating or approximate. Okay, and we do this all the time with pi. We could say pi is about, wavy equal sign means pretty close, 3.14. Okay, you could even say it's about 3. It's close to 3. Okay, pi is close to 3. So 9/4 is close to the square root of what integer? All right, let me talk about some square roots that I know. Here's the square root of 1. I know that's 1. Square root of 4, I know is 2, because 2 times 2 is 4. Okay. 9/4, I mean, how big is 9/4? Remember that 9/4 is 9 divided by 4. Okay, 4 goes into 9 twice. 1 left over. Just rocking a little long division here. And this will also show you what it means to have a decimal terminate, because this one's going to terminate. 4 goes into 25 times. Okay, so 9/4 is 2.25. My division terminated because it got to 0, no remainder. Okay, so 9/4 is 2.25. That's going to be about right here. Okay, and then what's over here at 3? 3 is the square root of 9. Okay, so 9/4 is close to the square root of what integer? I think it's going to be closer to 4, right, than it is to 9. Okay, because 2.25 is really closer to 2 than it is to 3. All right, so that's what's going on here. You're using the numbers that you know the square roots of. Okay, we know the square root of 1. 1 times 1 is 1. We know the square root of 4 because 2 times 2 is 4. We know the square root of 25 because 5 times 5 is 25. All right?